Endothermic and exothermic reactions, which potentially you've learned about this before. You can break down these words and think, what does endo mean? What does exo mean? And then we've been talking about thermic and thermodynamics and the idea of heat. So energy and chemical reactions. Write this down in your notes. That chemical energy is energy stored in the chemical bonds of a substance. This is a review from previous in the year as well as physics. Chemical reactions always involve energy changes because we have making bonds and breaking bonds in order to create these energy changes. Next, we're going to talk about activation energy. This is the energy required to break the bonds in the reactants for a chemical reaction to then occur. We see this here. This is just kind of a funny cartoon saying we must supply energy to break the bonds. Super hard to break them, so we have a strong man coming breaking those bonds. So endothermic and exothermic reactions. Step 1, energy must be supplied to break the chemical bonds of the reactants. Then energy is released when new chemical bonds are made in the products, which we see that picture in there. So here it's breaking, and then here it's coming together. So energy is released when new chemical bonds are made, and then we needed chemical energy to break that bond. Reaction is exothermic if more energy is released than supplied. So exothermic, we have more energy exiting, being released, and then if more energy is supplied, so more energy coming in, if more energy is supplied, then it's released, so more energy coming in, endothermic. So I think N in exo, exiting. Energy of chemical reactions. Based on the type of energy, heat, change involved, chemical reactions are classified as either exothermic or endothermic. Make sure you write this down. Exothermic, like we said, energy is released, and endothermic, energy is absorbed. An example of exothermic would be burning of gasoline. An example, because things are coming off, energy is being released, you would feel that fire and heat exiting. Then endothermic, an example would be cooking pancakes. Energy is absorbed to cook those pancakes. Here is a graph of an endothermic reaction. Write this, show this graph in your notes. Notice that we have less reactants, or we put in less reactants and get out these products versus the whole entire thing. So the activation, we needed a lot of energy. We put a lot of energy in, entered a lot of energy to break those bonds, and then all of this energy was absorbed in the reaction. And then over here, the energy was released in the bond making. So we see we put more energy in than what came out. So make sure you write this information in so that you understand why is this an endothermic reaction. More energy was absorbed. Endothermic, like we said, more energy is taken in to break the bonds in the reactants than released by the bonds being formed in the products. Therefore, energy is absorbed. Here is another way we can look at it. I like this picture, and you could write this down too. Endothermic, again, we said heat or energy is taken in. The temperature of the substance drops. So thus the product would feel cold. So like an ice pack that you break would actually be an endothermic reaction because it feels cold, the temperature falls. You may see an endothermic reaction written like this. Reactants plus a lot of energy that's absorbed yields products, or reactants plus heat yields products. We're going to switch gears and talk about exothermic reactions now. So this, of course, again, we have chemical energy increasing this way, the reaction progress increasing to the right. If we put in a lot of reactants, we see this right here is the activation energy. This is the energy released in the bond making. So we see that exothermic, more energy is released. We have more energy is released when the products were formed than energy was used to break the bonds in the reactants. Therefore, a net release of energy. We have more energy being released. So again, we see how that's different than this graph, where we have less energy. Then exothermic, we said heat or energy is given off, it's exiting. So the temperature of the substance rises. If we put a thermometer in it, we would see it and the product would feel hot. You may see exothermic reactions written like this. The reactants yields products and energy, or the reactants yields products and heat. Very similar, but opposite to the endothermic reactions. Here are these two endothermic or exothermic? Well, this one we're putting in more energy, so therefore it's endothermic. This one, energy is being released, so it is exothermic. This here, again, a fire would be exothermic because energy is being released, and then a snowman that's starting to melt, bringing heat in, it would be endothermic. Here are some practice questions, so write these down in your notes and then make sure to submit a clear picture on Google Classroom for your homework for today. Thank you.